All right, good evening and welcome to Maths and Talker online class. Today, we'll be solving some important questions on complex number. Okay, from the past question. The first one said, find the principal argument of this. I noticed that when they want to ask you principal argument, they ask you principal argument on the fourth quadrant. If you look at it, this is fourth quadrant. Why? Because normal argument is the same thing. In fact, it's the same thing you will get for first to third quadrant. It's the same thing. It's only in the fourth quadrant that you have that if here now is alpha, then if theta is your principal argument, principal argument is equal to minus alpha. Okay, and what is your alpha? Don't forget, alpha is equal to what? The tan inverse of absolute value of what? Y over x. For principal argument, okay, for principal argument, we always have that what? We always have this absolute value. But in your normal argument, there is no absolute value there. But after doing your calculation, you see that in the first, second, third quadrant, the argument and the principal argument are the same thing. Okay? Only in the fourth quadrant. Okay, so now in this third quadrant, if it is third quadrant, here is your alpha. You are going to have that your principal argument theta is equal to 180 plus what? Your alpha. Don't forget what your alpha is. Then in the second quadrant, here is alpha. Your principal argument is equal to what? 180 minus, in fact, not this, sorry, it's supposed to be alpha minus 180. Alpha minus 180, I be 180 plus alpha. You will check, just so that anything you are doing should fall within the third quadrant. Okay, so this one is theta minus alpha. Okay, while the first quadrant remain. But where they normally ask you question is only on the fourth quadrant. So just don't forget that in the fourth quadrant, that your principal argument theta is equal to what? Minus alpha. So I'm going to get that what? This is let z, which is equal to x plus iy, equal to what? Or yi, anyone, equal to 1 over 2 minus 1 over 2i. Okay, so if you draw this, before you get anything argument, you need to draw it. If you draw this now, you see that you'll be having that x is positive, this is positive x, y is negative, this is negative y, 1 over 2 minus 1 over 2. You see, where did they fall? They fall in the fourth quadrant. So this is fourth quadrant. Don't forget that theta in the fourth quadrant is equal to what? Minus alpha. So let us get that. My alpha is equal to what? Tan inverse of the absolute value of y over x. Don't forget that absolute value will always make it positive. So my alpha is equal to what? Tan inverse of y is minus half. Minus half. I will use this kind of divide. Divided by x is half. Whenever anything divides itself, the answer is 1. So because of this minus, absolute value will take care of the minus. So my alpha is equal to what? Tan inverse of 1. And tan inverse of 1 is what? Tan what to give you 1? 45. So my theta, the principal argument theta, is equal to what? Minus alpha, which is what? Minus 45. If they want you to put it in terms of radian, you have what? Minus 45 pi over what? 1/8. So you have 5 into here. You have what? 9. 5 into 15. You have 3 into 30. 5. Am I correct? 5 into 30 is 6. So this is pi over 4. Minus pi over 4. So that is your answer. Okay, that is for principal argument. Okay, please don't forget that. It always comes out in your exam. I've seen it in your past question countless times. Okay, so don't forget about the principal argument. So know the difference between the principal argument and the argument itself. So the second question we are going to solve said simplify 6 plus 4i e raised to power I pi over 3. Okay, before you simplify this, let us simplify only this one first. E raised to power I pi over 3 is the same thing as saying what? Cos what? Cos pi over 3 plus what? I sine pi over 3. Okay, so what do we have now? Cos pi is 180. 180 divided by 3. 180 divided by 3. So I'm having 60. So cos 60 plus what? I sine 60. So and cos 60 is what? Cos 60 is 1 over 2 plus what? I sine 60 is what? Root 3 over 2. So since you have gotten this, now use it and multiply this one. So therefore, my 6 plus 4i e raised to power I pi over 3 is equal to, so is equal to what? 6 plus 4i in bracket of what? 1 over 2 plus what? I root 3 over 2. So let's go. In multiplication, this first one will multiply everything and the second one will multiply everything. So this time this will give you 3. This time this will give you plus what? 3 root 3i. Okay, let's go to the next one. This time this will give you 2i. This time this, first of all, the number times the number will give you 2 root 3. Then I times I will give you minus 1. So your final answer becomes, let me write it here, 3 plus minus is minus 2 root 3. This is the real part. Then the imaginary part is 2 plus 2 plus 3 root 3. 3 root 3. And all of them have what? I. So this is the final answer. This is the real part and the imaginary part. Okay. So number what? Number 3. Some important questions on sword you will encounter. Number 3 said that if z prime like this, z bar plus 2z is equal to 3 minus 2i, then I say we should find z bar. Please, z bar means the conjugate of the complex number. We know that normally the complex number z is equal to what? X plus iy or yi. Then z bar is the conjugate. So change it to minus, which is what? X minus iy. So let us put it in this equation. So this one is x minus iy plus 2 brackets x plus iy. Okay, they say is equal to what? 3 minus 2i. Okay, so let us clear the bracket here. If we clear the bracket here, we now have x minus iy plus 2 times this 2x plus what? 2yi is equal to what? 3 minus 2i. Okay, so is there anybody that can add? This can add this. This plus this will give you 3x. This can add this. 2y minus y will give you what? Will give you plus y. Don't forget they have I. So yi is equal to what? 3 minus 2i. So compare. By comparison, you are having that what? 3x that does not have I is equal to 3. And the y that has I is equal to minus 2i. So what do we have now? This cancel this. I'm having that x is equal to what? 3 over 3, which is equal to what? 1. Okay, so I cancel I, so I'm having that y is equal to what? Minus 2. So therefore, my z bar, which is equal to x minus iy, is equal to, I've gotten x to be 1 minus I into minus 2. So which is what? 1 plus 2i. So that is my z bar. Okay, thank you very much for this. So let's continue number 3. So these are the kind of question that you may encounter that I did not treat. So it's there, but I just want to make it clear for you. Okay, number 4. Number 4 said find the real part of z raised to power 3, which is an element of a complex number. Solution. We know that z is the same thing as saying x plus what? yi. Okay? Which is the same thing as saying the same z is the same as saying r bracket what? Cos theta plus what? I sin theta, which is equal to what? I e raised to power what? Sorry, r e raised to power what? I theta. Okay, so but I want to use this. For instance, I'm going to have that z raised to power 3 is equal to what? R bracket cos theta plus what? I sin theta. Then all raised to power what? All raised to power what? 3. So if you clear, you're having that r raised to power 3 in bracket of what? Cos 3 theta plus what? I sin 3 theta. Okay? So the real part, if I use this to clear, I'm going to have r raised to power 3 cos 3 theta plus r raised to power 3 I sin 3 theta. So the real part, this is the real part. So the real part re of z is simply what? The one without I, which is what? R raised to power 3 cos 3 theta. As simple as that. You see, they don't have questions to ask. Very, very simple questions. So, number 5. Number 5. Number 5 said find the polar form of 1 over 3 root 2 bracket 3i minus 3. Okay, I'm going to solve this in 2 ways. Okay, the first way they said is z is equal to, let me multiply. This time this will give you 1 over root 2 I. This time this will give you 1 over root 2 minus 1 over root 2. Okay, let me arrange it very well. The real part first before the imaginary part. So this is equal to minus 1 over root 2 plus 1 over root 2. Okay, and in trigonometry, the only thing that will give me 1 over root 2 is cos 45 or sin 45. So this is saying that z is equal to what? Cos. Sorry, there's I here. I, okay. So, but cos is an even number, so I cannot have minus there. So let me bring out minus. If I decide to bring out minus, I'll have 1 over root 2 minus I minus 1 over root 2i, 1 over root 2i, okay? So which is what? Minus bracket. This one will give me cos 45 minus I sin 45. So what am I having? So the polar form is going to be minus cos 45 plus I sin 45. Okay, so did we check where we are supposed to check the quadrants? We did not remember the quadrants, so let us check the quadrants. Okay, let me leave this thing like this and solve it with the normal method. This method is always confusing. Let me solve it with the normal method. The normal method is by saying we know that z is equal to, if I clear, we got minus 1 over 2 plus what? 1 over root 2i. So what do we have? We are having that our x is equal to minus 1 over root 2 and our y is equal to 1 over root 2. Okay, our radius r is equal to what? The square root of minus 1 over root 2 all squared plus 1 over root 2 all squared. So our r is equal to the square root of 1 over 2 plus 1 over 2. Yes. And half plus half is 1, which is equal to what? Square root of 1. which is 1. Okay, we've gotten our r to be 1. So the next thing we are going to get is the theta. But before we get the theta, let's find out the quadrant. So this one is minus x, which is this side, and this one is plus y, which is this side. So they are in the second quadrant. So anything I'm getting will fall within the second quadrant. So we are supposed to apply that law here. I'm coming for that. So since it's in the second quadrant, I'm going to have that what? That my theta is equal to what? Tan inverse of tan inverse of 1 over root 2 divided by minus 1 over root 2. So anything divide itself is 1. So I'm having that theta is equal to tan inverse of what? Minus 1. So which is what? Minus 45. Okay? But I'm not going to use minus 45. So my theta is going to be 180 minus 45. So my theta is equal to 180 minus 45. So 135. So my answer finally becomes z is equal to r bracket cos theta plus I sin theta. I love this method. This one is easier. So my r is 1 bracket cos what? Cos 135 plus what? I sin 135. So that is that. Okay, thank you very much for watching this one. So but we can still do the same thing here. But please follow this method. This method is very simple. Okay, I can clean. So the next question, number, is there any other question? Okay, they said, the last question I'm going to solve here said that if z raised to power 5 is equal to minus 1, they said we should find z. Okay, solution. So what do we do? It's getting that. What do we do? I have z will now be what? Minus 1 raised to power what? 1 over 5. Is it not? So this thing is the same thing as saying z is equal to minus 1 plus 0I all raised to power what? 1 over 5. Is it not? So let us follow our normal method. And our normal method is, first of all, let's change it into polar form. So I have minus 1 plus 0I should be equal to what? The first thing we are getting is our r. Our r is equal to the square root of what? Minus 1 all square plus 0 square. So what do I have? The square root of 1, which is what? 1. Our r is 1. So let us get our theta. Our theta is equal to tan inverse of what? 0 over 1, which is what? Tan inverse of 0. And tan inverse of 0 is what? Minus 90. Let us check it though. This is 0 over minus 1. Okay, which is even 90. Because anything divided by 0 is 0. So which is 90. I'm having 90. So since I have 90, so my polar form is going to be what? My polar form is going to be z is equal to what? 1 bracket cos 90 plus I sin 90. Okay, so the 1 does not mean anything. So z raised to power 1 over 5 is equal to cos 90 plus what? I sin 90 all raised to power what? 1 over 5. Okay, so let's go. Don't forget that this will be equal to what? This is equal to what? Cos theta plus 2k pi. Theta plus 2k pi all over n plus I sin 2k pi. Sorry, I plus I sin theta plus 2k pi all over n. Okay, so where k is equal to 0, 1, 2, 3 and 4. So you can now substitute. Your theta is 90, so substitute and tell me what the final answer is at the comment section as it's getting dark. Thank you very much for watching. We really appreciate